Hello everyone. I hope that you have had good time with Solita Summit so far, and thanks for joining my session today. My session is about architectural fundamentals of cloud resilience. So it is really important topic nowadays, and let's dive in. My name is Heikki Simperi, and I joined in 2007 to Solita, and I work as a lead cloud architect role currently. I have over 25 years experience in software business. Actually, I started using AWS as a public cloud vendor in 2008, and first production launch was a small ERP solution in 2009 in the AWS Ireland region. So, this is one of my favorite quotes by Werner Vogels, CTO of Amazon.com. He said that everything fails all the time. So that's why we need to have resilience in our cloud infrastructure and cloud architect built in. Today, my agenda for this presentation is definition of resilience. Then we go through what customers are expecting when they are willing to order cloud infrastructure from us. Then we go these basics of isolation boundaries, what it actually means, why it is important. Then I will show 6 different architectural patterns that you might use to improve cloud resilience in your architecture. And then finally we have a summary of all of this. I got my inspiration from presentation by Schmitz, Critelli, and Dalmolin from AWS. They held this webinar about design resilient workloads on AWS in few months ago. Other material that I have used is well-architect frameworks from AWS and Azure. So let's define the resilience. So basically it is the ability of a system to maintain its functionality and quickly recover from infrastructure failures or service outage. Ability, maintain, functionality, recover, failures, or outage. Yeah, that is our definition for resilience today. So let's dive in what customers are expecting from us. So they want to have different topics that is really important to them, and it depends from each project that what is the actual meaning of business continuity, data protection, and so on in that certain case. But let's go in a high level what this means. The business continuity basically means that they want to minimize operational and financial risks of downtime that downtime can cause. Then the data protection, it basically means that the data that they have decided to save in the cloud or have a persistent data, it needs to be secure and it should not be lost or corrupted. Also, the integrity of data is really important, that they know that where the data changes who has done those. Then the third one is customer trust, that they want to have reliable services that are running 24/7 all the time in a good manner or good service level. So basically that means that they want that services are reliable, that customers are coming back. Then the fourth one is regularity compliance, that basically all the systems that, for example, use personal data or store personal data, they have to follow the regulation of personal data handling. For example, in the EU, it is something called GDPR. Also, for some other sectors that are really important for countries or societies, they might have even uptime requirements. But these are like the requirements, and then of course there are those other boundaries that each project has. So for example, the schedule, cost and scope is something that is always like limiting our choices, what we can do to meet these requirements and expectation of customer. So let's remember that outside of each project or customer case, it is really difficult to see the whole picture of what looks good resilience or what success resilience looks outside. So let's dive in the isolation boundaries then. We will go through two different isolation boundaries. One is physical boundaries, and then the other one is what makes it different between control plane and data plane. First, let's go physical boundaries in the cloud. We can divide the overall setup of public cloud to 4 different sections: global, regional, availability zone, and servers. So in a global level, if we are using the default public cloud platform or the entity, it is the commercial entity typically. They have shared services like identity management and billing data. And those are stored in centralized place, or that place that you cannot really affect easily. But there are also other entities. For example, China has their own entities that it is a small, only few regions in a small area of the world. Then the global level, each global entity has tens of regions, and one region contains or consists of several availability zones. So when you are storing, for example, personal data that the customer is using, then you need to select the correct region location. So it is the data residence area in that sense. Then the region is contained of availability zones. So one availability zone consists of data centers. Those are those physical buildings which have redundant power and internet connectivity. For example, they have multiple internet electricity providers or lines to the main network. Then finally, each data center finally consists of servers, which are the physical equipment that is behind all services. So disks, fans, power outlets, and so forth. So this is the physical world. And it is always we need to understand the relationship on that. Then control plane and data plane. Control plane is the overall picture that is the cloud management layer. That if you do some changes in your infrastructure, you use control plane. It is lower volume that you will use, but there could be a complex relationship of resources and physical world. Then that's why there is a higher likelihood of failure. Then the other one is data plane, which is the application execution layer. Basically, all the business transactions that your application is doing. That could be a really high volume, hundreds of or thousands or anything number per second of those transactions. It is really critical because every downtime matters on that sense, but luckily it's much more simpler and we don't have so many problems on that sense, or that layer. So we need to rely the data plane and static stability much more. For example, if we are designing a high availability solution that uses standby and primary sides, we need to have that kind of switch logic in the data plane manner that it is basically, for example, health checks in DNS server, and it is not on the control plane that when we noticed something and we want to run some configuration changes to make that switch from to the standby region. So we need to rely on data plane automation and not control plane configuration changes on that. So let's dive into architectural patterns. So failures are inevitable and resilience is optional. So we need to take care of that design at early stage. I have divided these fundamentals in 3 different sections: regional, multi-regional, and when we are thinking about beyond a single cloud. So the first one is the regional level. So we should use always, if it's possible and affordable, the cloud native managed services. So of course there is the micropayment or micro license in each hour that we use or each request that we use, but those are really those services that we can easily rely. Then the other one is that our deployment should automatically use multi-agent environment. So if one availability zone will have a problem, the service should go on the other availability zone automatically. And the third one, which goes in all of these sections, is that we should be able to make those improvements to the cloud infrastructure in a production environment all the time. So if we are using ClickOps methods, that might be difficult to understand what is the testing environment situation or status and what is the production environment status. But if we are using those good ways of infrastructure as code and CI/CD pipeline, we can see the difference between each environment much more easily and make those small changes very regularly. Then the multi-region level. Then it's important that if the business continuity requires it, then we go to multi-region, but let's make sure that we handle how the persistent data is really replicated. That is really difficult. And the last one is the hybrid or multi-cloud environment, which is basically already that we are doing some configuration and some solutions already in 2 different ways, and everybody understands that it has a cost of doing that, and it can even be too complex to be working what we are expecting to it need to work. So that is the most complex and most cost way to run the solution. So we have 6 different patterns. Let's go the first 3 ones. And the first one is that we talk about the isolation boundaries. So we need to understand how we can have the fault isolated. So basically it means that if there is some kind of outage, partial outage, which is the most typical method, then the customers, for example, should be able to still do online shopping, but for example, last viewed items would not be visible. So gracefully have this kind of avoiding those last viewed items. Then sufficient capacity, instant scaling. With virtual machines, we can scale in minutes if we notice that requirement, but with containers and functions, the scaling can happen in seconds. If we do it in minutes, then there is could be some outage for the clients. Because those failures happen all the time with our application, all the infrastructure, then we need to have the automated recovery always. So if something happens, there will be an automated recovery. For example, unhealthy containers are recreated automatically. Then we need to protect the backend in higher volume of requests or some other problems. So there should be a protection layer for reacting or slowing down excess requests. It might mean that, for example, the API gateway or the API resource does throttling to prevent this happening. So it is not wise to do too much request if something is already slow. Then we need to have a really good monitoring and observability tooling that, for example, if we have a lot of microservices, we need to have distributed tracing that can pinpoint those microservices that are causing high delay. So that is really important in that matter, that we have a good monitoring capabilities. And as a last one, the data durability. So basically, if we are using managed services, they are always documented which service is the durability of this service. So if we need certain durability percent for our data, we need to take care of that. So for some it means that we should not use the local storage, we should use the network storage and even object storage. In database manner, it might mean that we should use certain product of database, managed service database, and in some cases even that we should have automated replication of database to other region to get the highest durability for the data transactions. Okay, then let's go in the summary of presentation. So like I said, that failures happen all the time. It is something that we cannot avoid. We should think about that. And isolation really matters because the public cloud is not a new thing anymore. So it is really uncommon to have widespread outage nowadays. So those are really bulletproof services for cloud providers. So those are often just concerning one service or one availability zone and so on. And right design is case by case. It depends of those customer needs and boundaries. And we need to understand that the customer often want to have a multi-cloud setup, but that is the last resort because it's most expensive, most difficult, and also that's why it's error-prone solution. And we need to take actions. The hope is not the strategy, basically. And if we start early, we can reach the finish line. Okay, thanks everyone listening my presentation, and have a good Solida Summit now on also. Bye.